This short clip is the first one in a video series on how to develop a custom embedded coder target for a hardware platform based on ARM Cortex-A processor. We cover three topics here: key terms and concepts, an overview of the target development process, and the required skill set for a target author. So what is a target? Your hardware board has a processor and supporting peripherals. A reference target is built for a specific processor. This will typically be provided by MathWorks. What you will create is a custom target built for a particular hardware board. Let's take an example. BeagleBone Black is a board based on ARM Cortex-A processor. MathWorks provides a reference target for ARM Cortex-A processors. Then you, the target author, uses this reference target along with the target SDK to expand the support for a specific board, in this case BeagleBone Black. The resulting target will have the following standard features. Application features generate application components and enable execution of an algorithm on the hardware board. Verification features generate instrumentation code that will verify your algorithm as it executes on hardware. This may be using processor in the loop feature or external mode and so on. Finally, deployment features allow the generated code to execute on the hardware. The key point here is that some target features are reused from the reference target, while others need to be implemented. This table gives you a sense for which ones are reused and which ones need to be implemented. So how does the process work? The development of a target for a given hardware comes down to providing hardware information in the form that the SDK understands. You follow these steps to complete the process. You gather the information about your hardware. This may include any source files and so on and so forth. Then you will write MATLAB code using the target SDK APIs provided with the support package. This MATLAB code will help encode the hardware information in a way that the SDK understands. The MATLAB code and the hardware information is then translated into a set of hardware info files. The hardware info files are used along with target features to generate code that runs on the hardware board. Now, before we get started, let's make sure we understand what a typical target author looks like. The target author brings expertise on the hardware platform and the related toolchain. The toolchain includes tools like compilers, linkers, and so on. With that, if you have working knowledge of classes in MATLAB and are familiar with Simulink, then you're ready to go. Rest of the videos in this series are hands-on tutorials to build an embedded coder target for BeagleBone Black. In the next tutorial, we will register the target.